And let me share my screen right now. Okay, as usual, any question just post it in the chat box. Okay, we are still in the same chapter, the last chapter actually. The last chapter is differential calculus. So we are looking at a bunch of scenarios where we are dealing with differentiation. It's not basic differentiation. Basic differentiation you learn in engineering maths 1. But these are more complicated scenarios where you will come across differentiation. So previously we have looked at curvature, radius of curvature, circle of curvature. So all these things are some scenarios where you deal with differentiation. Today, we are going to look at another, is it a type? No, another scenario of differentiation, which is slightly complicated than basic differentiation. Let me show it to you now. Okay. All right, so I believe you can see my screen right now. Now, maybe I shouldn't start from this thing immediately, but let me tell you what's the purpose of us learning this right now. Okay, usually, okay, you can derive almost anything, right? When you have differentiation, okay, that's too big. Give me a moment. Okay, so when you derive something d over dx, the thing that you're deriving can be anything. It can be an expression, it can be a constant, it can also be an expression containing an integral. It can happen. Okay, let's say this. Okay, it means that you integrate x squared and then you differentiate it back. Can you see there are two opposite operations on it? You integrate x squared, you differentiate it back. So you don't even have to calculate anything. The answer is going to be x squared. The differentiation and the integration cancels out each other. Okay, similarly, I could say that, let's say you differentiate the integral of something very complicated, ln x squared over ex plus sine x. Okay, let's say we do that. At the end of the day, you don't have to compute it because you integrate something and then you differentiate it back, you are going to get back the same thing inside the bracket. So in that sense, when you have a derivative of an integral, it's easy. Okay, it was easy because everything inside here is just x, everything is x. But what if, let me show you another scenario. All right, now, what if you consider this case? Okay, ignore the formula for the moment, but let's just look at the type of the expression. What if you have something like this? Okay, you have a derivative of an integral, fine, looks easy. However, can you see that the expression inside here not only contains x, it has a x and it has a t at the same time. Okay, so you cannot simply claim, I integrate and then I differentiate back, I will get the same thing. No, why? Can you see you integrate with respect to t, but you differentiate with respect to x, two different variables. So in this case, the differentiation and the integral doesn't simply cancel off. You integrate with respect to t, but you differentiate with respect to x. So it doesn't work the way that we did previously. So you need something else when you're differentiating an integral, but the integral unfortunately has two variables and you're integrating with respect to the other variable. Okay, so one way to deal with it is that we have something called Leibniz integral rule. Okay, it's a rule used when we are dealing with scenarios like this. The rule itself at first glance might be extremely complicated. Okay, like the answer is so long. However, let me break it down for you how to see it in a more easier way. Okay, let's look at this. I know that there's a bunch of things inside here, but let's break it down. First of all, we have this. Okay, we have fxv. How to find it? I will tell you in a while, but right now, just bear with me. We have fxv, and okay, and we have fxu. We have fxv, we have fxu. And then we have dv over dx. We have du over dx. And finally, we have the integral of the whole thing here. Sorry, the derivative df over dx. We have the derivative of the whole thing here. It's like they push the d over dx inside here. Imagine that. So you push the d over dx inside here, it becomes the derivative of f. Okay, it was confusing, but let's just okay, let's just stay here for a while. Five components. Whenever you want to use Leibniz integral rules, there are five things that you must find. So the easiest way to proceed with this is not to put everything in one shot, but to find them one by one. Let's find this, let's find this, and this. Let's list down the five components needed in the formula, simplify it if necessary, and then put it in. If you do it that way, you won't get lost. Okay, but if you put everything at one shot, chances are, if you get the wrong answer, you can't even identify what went wrong because you do it in one shot. Okay, so let's try this out. Let's try the five components for this one example. Okay, this is an example, okay, where you have a d over dx. However, you are integrating with respect to t, and again, there's an x and t inside there. Okay, so it fits the scenario that we are dealing with right now. So how are we going to do that? Let's find the first five components. The first thing I want to find, okay, is fxv. Okay, what does it mean by fxv? Okay, let me zoom in a bit. Fxv means that this whole thing, you know, the thing inside your integral, this is your f. Just remember, not including the dt, not including that, but the whole expression inside your integral, that is your f. So what this tries to say is that inside your f, there's x and t. Okay, there's x and t. So keep your x as x, but your t, change it into v. Okay, again, the x, keep it as x, no changes, but your t, change it to v. What is your v? Your v, let's look at the formula back. Can you see? V is your upper limit. U is your lower limit. That is your u and v. Upper limit and lower limit. To say that, this is your v, the upper limit, and this is your u, the lower limit. Okay, let's do that. Okay, so I have an expression here. I'm going to remain the x as x, no changes on that. But the t, I'm going to change it into my v, which is 2 over x. I'm going to change it. Okay, let me do that. And then this again, it's a t. So t, I'm going to change it. I'm going to change it into my v. So 2 over x. So there you go. That is the meaning of fxv. All the t's inside the integral, I change it into v, where v is my upper integral. And I see that it's a bit complicated, so I don't want to leave it in this form. Let me just simplify it a bit. So x and x cancels off. What we have is a sine 2. Okay, over 2 over x. So I can put the x here. Okay, 2 over x. This is equal to x sine 2 over 2. Okay, the 2 over x, I just change it. So it becomes x over 2. Anyways, that's the simplest version I can write for fxv. Let me repeat the same thing for fxu, because I also need fxu. So fxu. Same thing. It means that you keep your x as x, but your t, you change it into u. What is my u? My u is 1 over x. Okay, I'm going to do that. My t becomes 1 over x. Okay, and again down here I have another t, so 1 over x. So simplifying this, cancelling off the x and x, changing the 1 over x into x over 1, I will have x sine 1 over 1. So over 1, I don't want to write it. Okay, it's over 1. So two things done. Next, what do I need? I need dv over dx. I need du over dx. Okay, pretty straightforward. dv over dx, du over dx. Okay, let me find. Okay, again, my v is my upper limit, my u is my lower limit. So dv over dx, dv over dx. My v just now was 2 over x. So when I differentiate 2 over x, I will get negative 2 over x squared. Okay, that's what I would get. And my u just now was 1 over x. So if I differentiate 1 over x, I will get negative 1 over x squared. Okay, so just take my limits and then differentiate it. So far, 4 components done. fxv, fxu, dv over dx, du over dx. And there was one last component to be done. This, df over dx. This is my last component. Take f and differentiate respect to x. Okay, I'm going to do that. Okay, so what is my f? My f is sine xt over t. Okay, that is my f. So my f is sine xt over t. So what I'm going to do is I'm going to find df, dou f over dou x. Remember, I'm differentiating with respect to x, not t. Okay, I'm differentiating with respect to x. Now, if the 1 over t, the t here is just a constant, okay? So don't use that in the differentiation. You are differentiating with respect to x. So differentiate sine xt, you will get cos xt. But don't stop there. Cos xt, right? Times chain rule, right? Sine xt. If you differentiate sine 2x, you will get cos 2x times 2, right? So in this case, cos xt times t. T is the constant beside x. And this is again just a constant. I hope you still remember partial derivative. Differentiate sine xt, you get cos xt. But by using chain rule, you differentiate xt, you get t. So therefore, I multiply that. Anyways, t and t cancels off. So what I have is only cos xt. This is what I get for my df over dx. So let me zoom out and show you what we have gotten so far. Okay, we have gotten 5 things. It's a bit small, but we have gotten 5 things. 1, 2, 3, 4, and 5. All the things needed in the formula. So now, let us plug it into this formula right here. Maybe can I drag it here for a while? Just for a while. Okay, just drag it for a while for me to show you how to put it back inside the formula. So according to the formula, the whole thing is equal to fxv. My fxv just now was x sine 2 over 2 times with dv over dx. dv over dx just now I got negative 2 over x squared. Okay, minus fxu. fxu I got it as x sine 1 just now. X sine 1. And then du over dx, just now I had negative 1 over x squared. Okay, plus, and then we have plus integral, put back your u and v. My u and v was 1 over x and 2 over x. df over dx, just now we already find it. df over dx, we got the answer was cos xt. And finally, dt. Okay, this is the expression. So finally, we just plug in everything that we have and do not leave your final answer in this form. Simplify and make sure you integrate the last part here. Okay, that's the whole point of it. So simplifying this, x and x cancels off, 2 and 2 cancels off. The negative is here. So negative sine 2 over x. Okay, here what do we have? X and x cancels off. Negative and negative becomes positive. So plus sine 1 over x. Okay, plus integrate cos xt with respect to t. Okay, focus on that. You are integrating with respect to t. So if you integrate cos, you will get sine. So you will get sine xt. Remember integration, if you integrate cos to t, what do you get? Sine 2t over t. So it's the same thing. Sine xt divided by the constant. What's the constant in front? It's x. As long as you can identify what variable you're differentiating or what variable you're integrating currently, you should be fine. Okay, so I hope it's not confusing why you have an x. Because integration says that once you integrate, you have to divide by, differentiate 2t, you get 2. Differentiate xt, you get x. Okay, because right now we are doing it with respect to t. So x is your constant right now. Okay, so let me simplify it again because I think it's possible. So negative sine 2 over x plus sine 1 over x plus, put in 2 over x here. Okay, if you put in 2 over x into your t, the x and x will cancel off. So you just have 2. Put in 1 over x here, the x and x will cancel off. So you have just 1. Okay, and finally, negative sine 2 over x plus sine 2 over x, sine 1 over x minus sine 1 over x. The final answer is just 0. In this case, everything cancels out. You only get 0. Okay, so I know it's an extremely long process, but that's how it works. I cannot simplify it any further. I think breaking it down into 5 components is the easiest way to deal with it. So let me show you. This was the first step. I found each of the things I need, the fxv, the fxu, the dv over dx, the du over dx, and even the dou f over dou x. I just list them out, 5 different things separately. And then I put it into the formula and I try to simplify it as much as I can. Okay, I know it's a long process. I wonder if I zoom out, you can see everything. Okay, maybe it's a very small thing, but maybe if you want to note down anything, take your time. I know it's a bit small because I want to show you another example. I want you guys to try out another example, but try to write this down on a piece of paper and let me know in the chat if you don't understand what is going on here. At any part, if you're confused, what is going on. The question, yeah, the question is small here. Or maybe I'll just, for the moment, okay, I cannot see the chat box right now, but just to show the question, yeah, this is the question. Take note of that. Okay, this. Those who are sending anything in the chat box, if any, just wait for a while. I can't see the chat box yet. So sine xt over t, and those are the limits. The formula itself is very long actually. So the limits are 2 over x, 1 over x. Let me zoom out again. Yep, so this was the whole process. Just want to check, anyone ask anything? Okay, no so far. I will share the whiteboard, so I don't expect you to write down everything, you don't have to. But just want you to be aware that these are the steps involved. Later when you're trying out another question, the derivative and integral will come naturally to you. I have a few students in my previous class who asked me that, so maybe you will ask me at one point as well, maybe, like how do we know which is the thing that are going to substitute our v? Because it's not always x and t. Sometimes they might give you r and s, right? Maybe there's, sorry, maybe there's r and s, maybe there's p and q. So then you will get confused, which one you have to substitute, which one you don't have to. The idea is that when you look at this formula, can you see that the outer variable is x, right? The outer variable is what remains. The inner variable is what we change into our v and u. Okay, so again, the outer variable is x, so you can see the x remains the x, the x remains the x, but the inner variable changes into v, changes into u, and things like that. And one more question, how do we know the expression inside to what variable I should differentiate? You should differentiate with respect to the outer variable. The outer variable is x, so therefore you differentiate with respect to x. It's like you're pushing this inside, so the dou over dou x comes inside. Okay, that's how it works. Okay, can we use t as u? As u? You mean you want to, oh, can we use t as u? What do you mean can we use t as u? The u currently is the lower limit, right? So I'm not so sure. You want to change t to be the letter u? Is that what you mean? For the question 1. Okay. So our u is 1 over x. So do you mean you want to change the t into u or something else? Or is it the final answer you want to put in your u or whatsoever? Not sure. Abdullah, by the way, the second class test is on this Thursday. Yes, our next class. Our next class is Thursday, is it? Our tutorial, the 1-hour tutorial, that would be our class test. Oh, instead of using 1 over x, can use t. Okay, so the thing is, in this part, right, the fxv, it asks you to substitute in v. So if you remain it as t, at the end of the day, you still need to substitute in, because your final form of this expression is that x is x, but your t becomes v. X is x, but your t becomes u here. So you can use t first, let's say during the integration or whatever, but finally, at the end of the day, you have to put in your v and u as well. Maybe you can try out one question. When you do one question by yourself, you can see what is going on here. Okay, let us see. How about this question right here? I'm going to show the question and the formula here, so you can refer both of it at one time. So try this out. Let me just give you a few tips on this. The outer variable is alpha. Okay, the outer variable is alpha, meaning that alpha is the variable that stays. The inner variable is x. So x is the variable where you change into v, you change into u, and so on. Okay, so this is the outer variable. This is the inner variable. So use the formula accordingly. Okay, try it out. Take some time. I will show you how it's done. So no rush, take your time, list down one by one. What's the first? What's the second one? What's the third one? And so on. Yes, I can show you the working of the previous, but just make sure that you've already write down the question here, because I want to move the whiteboard. Because if I show you the solution, okay, what can I do? Let me see. All right, give me a moment. Let me screenshot the formula and the question and then put it in the chat box, and then I'll show you the working in front here. Okay, give me a few minutes, one or two. Let me quickly do that. Okay, anyways, instead of doing that, I changed my mind. I'm going to export the whiteboard here in the chat box. I'm going to put it there. Okay, so far what I've written, I've just attached it. Just wait for a while. Okay, now you can look at the question. Okay. So there you go. This is the question and the formula. The solution for my previous one, you can check in the attachment here. For 3, we should differentiate. For 3, okay, we should differentiate 1. Yes, correct, correct, correct. So this is your V, so you should differentiate 1. If you differentiate 1, you get 0. So yes. Can you explain dv over dx? Okay, for example, dv over dx, what do you mean is the number 3? Okay, third point. All right. Okay, so for example, in the previous question, my v was 2 over x. Okay, so my v is pretty straightforward. V is 2 over x. So dv over dx, just differentiate this with respect to x. So this is actually 2x to the power of negative 1, right? So if you differentiate, you get negative 2x negative 2. Or, in other words, negative 2 over x squared. So that is your dv over dx. Just differentiate your v. Done. End of story. So in this case, for this question, your v is 1. Okay, so your v is 1. It means if you differentiate v with respect to x, differentiate any constant, 0. So this is your third point. That is your dv over dx, 0. Was it clear? It's just a basic differentiation of whatever your v is. Your v can be constant, it can be a short expression, it can be long, it can be anything. Okay, good. So if any of you did get the final answer, just let me know. You can show your solution in the chat box or just your final answer. I can check it for you. So I wonder how it's going there so far. Let me carry on with your solution. I don't know how you guys are doing. Are you completely stuck, or are you in the process of doing it? Just let me know. So whether you're still doing it or you're already done with it, just let me know. It's fine if you say no, I can show it to you, okay? So just let me know how it's going so far. Okay, then I think we can assume that the majority still can't do this type of question. It's fine. Okay, so let me repeat the same thing that we did for question number 1 as well here. We have 5 components that we must find. But let me remind you that your V and U in this case are constant. For number 1, the difference between the second question and the first question is that for the first part, both of your limits are variables. But for this case, it's constant. The way of doing it is the same. There's no changes in it. But the only thing here is that because of the constant, you will see that it's way easier and the formula will be much more simplified compared to the case of question number 1. Okay, let's see how it goes. Let me here. Alright, fine. Now, the first component we must find is fxv. I know I should find that, but I'm going to leave it for the moment. The first component, although we need to find it, I'm going to leave it for the moment. Question part number 2, I need to find this fxu. I know I need to find this, but let's just leave it. The reason why I'm leaving it is because for part number 3, which is dv over dx, your v in this case is 1. So if you differentiate a constant which is 1, you will get 0. So my dv over dx is 0. Okay, component number 4. Number 4 is du over dx. du over dx. My u in this case is 0. You differentiate 0, you get 0. So again, my du over dx is 0. So one thing to keep in mind is that when you have your limits as constant, your upper limit is a constant or your lower limit is a constant, when both of them are constant, you are going to get 0 no matter what the constant is. So imagine this is 0, this is 0. 0 multiply with anything beside it, at the end of the day, the whole thing is going to be 0. 0 multiply with anything beside here is still going to get 0. So the whole front part is going to be 0. Okay, just because you get this and this is equal to 0. So the key takeaway here is that although we do it the same way, you will realize when you do it, at the end of the day, whenever your limits are constant, the whole front part will disappear. So what remains is only the final part. So you don't even have to find this. It's not needed. It's going to be 0 anyways. No matter what it is, you multiply with 0, it's still 0. Okay? But anyways, let me see number 5. Number 5. Number 5 is dou f over dou x. It means that I have to differentiate whatever that is inside here with respect, again, with respect to the outer variable. Keep that in mind. With respect to the outer variable, in the formula, x is the outer variable. That is why we differentiate with respect to x. So don't differentiate this with respect to x. Don't do that. Why? Because the outer variable is alpha. You have to differentiate with respect to the outer variable. So imagine this whole thing, we differentiate with respect to alpha. Okay, let's do that. Okay, so x is a constant, x is just a constant. So what do you get if you differentiate constant to the power of something. For example, if you differentiate 2 to the power of x, do you still remember what you will get? If you differentiate 2 to the power of x, you will get 2 to the power of x again times ln 2. That is what you will get. Okay, so if you differentiate x to the power of alpha, yes, exactly, Felix, exactly that. So dou f over dou alpha is x to the power of alpha ln x. Okay, differentiate 1, you get 0. Ln x is just a constant, so just leave the constant here, right? For example, 2 to the power of x over 3, we won't do anything to the 3, right? The 3 is just a constant there. So doing this, I see that I can simplify ln x and ln x. At the end of the day, I just get x to the power of alpha. That is dou f over dou x. So when I put it into the formula, the whole front part 0, the whole second part 0, but this part I have to compute it myself. Is the integral of u to v. What is my u to v? 0 to 1. Okay, it's not obvious here because it's blocking. Okay, my u is 0, my v is 1, so 0 and 1. The dou f over dou x, I get x to the power of alpha. Integrate with respect to inner variable. What is the inner variable just now? X. So the inner variable is x. Keep it, x. So what do we get if you integrate x to the power of something? For example, x squared. If you integrate, you're going to get x to the power of 3 over 3. So if you integrate this, I'm going to get x to the power of alpha plus 1 over alpha plus 1 from 1 to 0. So put in my x to be 1, 1 to the power of alpha plus 1. 1 to the power of anything is 1. Put in 0, 0 to the power of anything, 0. So 0 over alpha plus 1. 0 over anything is 0, so your final answer is just 1 over alpha plus 1. Can you see what's going on here? Try to have a look at this. Which part do you think is not so clear? Let me know. The purple one is my working here for question number 2. So at any point, if it's not clear, I can repeat. Maybe what you can do is take a piece of paper and try to do question number 2 again, but now you have a guidance here. Try to follow along if you can't do it. See whether you can arrive at the same conclusion as me for each of these.
Hello. Hello. Hello.
So every time you're dealing with Leibniz integral rule, find the five components. That's the first thing. But of course, since I know the limits are constant, since I'm going to get dv over dx is equal to 0, so there's no need for me to find 1 and 2. Because 1 and 2, no matter what it is, you multiply with 0, it's still 0.
हाँ ये तो बंदा एक बंदा करता है 17-18 कितने
So how about now? Is it a bit more clear on how to do number 2? If yes, I won't repeat it again. But if no, just let me know which part that I have to repeat again. The only thing that might be slightly confusing for you, I think, is the integral part. Because you have to differentiate respect to another variable, you are confused which part to make it as a constant, which part to make it as a variable. But that's why I say the key thing to identify is, first thing, with respect to what variable are you going to differentiate? It's the outer variable. If the outer variable is alpha, then differentiate the whole thing with respect to alpha, because it's like you're bringing this inside. And then how do you know with respect to what variable can you integrate? You integrate respect to the inner variable. Can we do step 3 and 4 first? Yes, yes, you can do it in any order you want. You can do 5 first and then 1, 2, 3, 4, up to you. As long as you find each of the 5 components. I understand what you mean, because when you find 3 and 4 first, it's clearer for you. You see it's 0, so you no need to find 1 and 2. It's fine. Okay? Whichever order it is. Okay, I see you're chilling there. So hopefully slightly a bit more clearer when you do the second example. Okay, the rest of you I'm not sure because only 17 of you responded here. Okay, so let's do another example. Example number 3. Again, by using the same formula, everything is the same. Same step, same formula. All right. Try out this question. Okay, you do have your whiteboard with you, right? You can also refer the question there, but this is the question right now. So the outer variable is x, the inner variable is t. Okay, so like this question, dx is for integration, and the earlier question was, okay, whatever the situation is, sorry, I just want to read this. We should do xv and xu. Okay. You should always take f, outer variable remains, inner variable change to u. Sorry, excuse me, excuse me. Yeah. Sorry, it's okay. All right, back to it again. Anyways, the question just now was that the outer variable should remain, but the inner variable is what you should change into x and v. So no matter what it is, for example, sometimes you might have a d over dq, and then inside here you have a bunch of r and q, right? So and then you're confused which one you want to do. So the thing is, the outer part will remain, so whatever that is q inside the expression will remain as q, but whatever that is r will change into u. Whatever that is r will change into v. So that's the way to identify, because it won't always be x and t. Was that a bit clear, Harish? So don't always fix x and t in your mind. Fix it like this. The outer variable remains, the inner variable changes. So keep it that way. So in this case, your outer variable is x. X remains, your inner variable is t. So all the inner variable changes. Did I use x accidentally? Oh my goodness. Sorry. You mean this part, right, Harish? I used x. Oh my god, so sorry for that. Okay, you are right. No wonder you're confused. I was wrong here. Yes, so sorry about that. So yes, it should be that the outer variables remains alpha, but the inner variable you change it to v. The outer variable remains as alpha, the inner variable you change it to u. And even this should be alpha, but then there's no changes, right? Because even one you differentiate respect to alpha also is still 0. So luckily, sorry for that, yes. Such a crucial thing, I made a mistake there. The outer variable, yeah, the inner is what changed. So this would be the, this remains correct. This is the outer variable. Yeah. So Harish, now it should be clear. Even for everyone else, it should be a bit clear. So sorry for that. Okay. the outer variable stays every single time. The inner variable changes. So in this case, your V is constant, your U is constant. So at the end of the day, you can compute it, you can write it, okay, you should write it. In fact, dV over dx is 0, du over dx is 0. Okay, so all of these things are 0 at the end of the day. Because they are 0, the whole front part of the equation is going to be 0. So what remains is only the fifth component. That's the only part that remains. So you have to figure out what do you get for your dou f over dou x. What do you get if you differentiate the expression inside here with respect to x? Why with respect to x? Because x is the outer variable. So I want you guys to try this out. Just let me know, did you get the same final answer as me, which is cos 2x minus cos x over x. This is the final answer that I got. So did you get the same thing? Just let me know in the chat. Okay, Felix got it. Nice, nice. If you can do it, it means that you understand how to use the formula here. So usually whenever you come across questions with constants, your work will be way easier. Because constants, every single time this will become 0. But whenever it's not constant, you can expect your working to be long. Because when they are not constant, you have to multiply, you have to bring the term until the final part, simplify it, so it will be way longer. That is why our example 1 is quite long, because it involves non-constant limits. Just going to wait for the others to see whether they get it or not. So while you're doing it, cos 1x and cos x the same. Yes, correct, Tanesh. 1 times x is x, so you can also write it as cos x. They are the same. Okay. So cos you differentiate, you get negative sign, but by using chain rule, right? When you differentiate tx, you get t. So that's why I have a t here. But then when the moment I put t, I see that the t here and the t in the denominator can cancel off. So that's the final thing I get for dou f over dou x. So the formula asks us to the final part, you have to integrate whatever that you just get with respect to the inner variable. So meaning that the whole thing that I just got, I have to integrate with respect to the inner variable. The inner variable was t just now, and the limit was from 1 to 2. Let me check. 1 to 2, correct. So if you integrate sine negative t, negative sign, if you integrate, you go back in reverse, you get cos. So cos tx divide by, right now you're integrating with respect to t. So your constant is x. So divide by x. And the limit is from 1 until 2. So finally, when you put in 2 and 1, that is where you will get the final answer that I got here. In case you are wondering, in your final exam, because this chapter will be coming for your final exam, the formula, the Leibniz integral rule will be given. It will be given. But then, of course, from the formula, you have to know what is your V, what is your U, what is your outer variable, inner variable. You have to understand the formula. But the statement of that formula, it will be provided in the formula sheet. Okay, so you don't have to memorize on that. But make sure you're not confused, like why suddenly you have U, what is U, what is V? You have to know that. And while we are talking about it, another careless mistake I don't want you guys to do is that, for example, when you use chain rule, because these kind of things are common, when you multiply negative sine tx multiply by t, don't multiply the t into here and say that the whole thing is negative sine t square x. No, it doesn't work like that. The t here is multiplied to the whole sign, not the thing inside the sign. It's multiplied to the whole sign. So at most you can write multiply t, that's that. You cannot combine the t outside here and the t inside the bracket. They're two different things. So question number 3 for me is slightly easier. So I'm going to repeat the same thing. I want to see how it goes this time. Just let me know your honest answer, okay? If you're still unable to do it, just admit, it's not a big deal. So I will provide you more questions, more videos after this so you can check it out. But just let me know, how did question 3 go? I see that you are beginning to get to how to do it after a few trials. Okay, one of you said no, it's fine, it's okay, just refer back. But right now, this is the solution, the one written in red. So the one guy who can't get it, just let me know if you are confused on whichever part written in red here. Or if you need more time, then take it, no problem as well. Okay, so everyone responded yes, 22 at least. The others, I'm not sure. Okay, so you guys can get it, which is good. After a few trials, you guys can get it. The only thing I would like to remind you is that if it's constant, it's easy, but don't forget that the question can also be in terms of variable. The moment it's in terms of variable, your V in U, it won't be equal to 0 and it will definitely be as long like this because you have to find each of the component. There's no 0 anymore. But if it is constant, then your life is way easier. The whole thing becomes 0 and 0. So only left with the final part. Okay, so that's that for Leibniz integral rule. So remember, your final exam will only be testing the final chapter, which is this, the one that we are learning so far. The part on vector calculus, the part on multiple integral, they won't be touched. Only one final chapter for final exam. So in that final exam, so far, we have touched radius of curvature, curvature, circle of curvature, the previous class. Today, we have touched Leibniz integral rule. For our coming class, we will be looking at something called PDE, partial differential equation. We'll be looking at heat equation, wave equation. So a very quick disclaimer, wave equation and heat equation, the solution is going to be abnormally long. It's going to be very tedious, extremely long. I wish I could tell you there is a shortcut for it, but no, it will be extremely long. That's how your current syllabus is. In the future, it might change, but for the current syllabus, the way we are going to do it is extremely long. So for our next class, which is Thursday, of course, it's class test, but for weeks after that, we are going to learn heat equation, wave equation, and then done. And then we are done with the whole module. So we have a lot of time to do revision. Okay, so for today anyways, I will post a YouTube video. I found a YouTube video on Leibniz integral rule. I will share it in the chat box. Okay, so we can have a look at it. There was a person was doing the question. There was some guidance on it. Which chapter coming for class test 2? Only chapter 2, vector calculus. Do you remember vector calculus? There's curl, divergence. We have gradient vector, directional derivative, Green's theorem, all those things. And those are the ones coming. Multiple integral won't be coming anymore for your class test. Okay, so do any of you have any questions right now regarding what we have learned so far? Otherwise, I want to give you guys your attendance. Okay, I'm assuming there's no question, or maybe you're typing it out, but let me still open the QR code for you to scan. Oh man. Okay, there you go. Yes, Lim, I can explain again on the outer and inner. Shouldn't we have a revision or no need for that? A revision, nah, I don't think you need revision, but extra, even when we are learning the chapter, right? We have a few external links, Abdullah, if I'm not mistaken. I did post some questions where you can try it out. So those links have a solution right beside it. You click on it, you can see the solution. So it should be a self-revision, should be self-explanatory. But if you're still stuck, you don't understand what's going on, you can let me know in the chat box. Just send me a personal chat. Okay. We have 4 absent, not sure technical issue or what. Okay, by the way, just now, Lim asked something on the outer and inner variable. So very quick one. You look at this formula, right, Lim? The part that I did say the x remains as x. The something changes into v and u, right? So the thing that remains is the part outside of the integral here. Can you see the integral and then there's a variable outside here? That is the outer variable. So outer variable stays as outer variable. But the inner variable, which is this, inside the integral is t, right? So your t is what changes into v and u later on. So that is the concept of outer variable and inner variable. Not too much to think about, just to make sure that you understand which is the part that you have to substitute your v and u into. Okay, anyways, for the rest of you, you have filled up your attendance, you are free to go. Okay, so I'll meet you during the class test for this coming Thursday then. So let me stop the recording and I will end the meeting in a while.